So it's 2 o'clock. I see a lot of participants are joining in, but I think we should start. So good afternoon to all. My name is Ana Afonso. I'm the head of the Nutrition and Food Innovation Unit at EFSA. And first of all, I would like to thank all the panelists and my colleagues that have been involved in the organization of this webinar. And of course, to all of you that have registered and want to attend. I think I would like to have just a brief overview of the agenda. Can I have the next slide, please? So we will have some opening remarks. Then we will have a more or less 45-minute session on an overview of the EFSA work on new genomic techniques, followed by a short question and answer session. We will have 10 minutes break. This is going to be a 3 hours event, so I think we need a little break. And then we'll move to our main interest, which would be an interactive moderated panel discussion. And then we hope to close 10 minutes for concluding remarks, and the event will be over by 5 o'clock. Can I have the next slide, please? So, first of all, this meeting is recorded, and all the presentations and the recording will be available in EFSA website after this event. I will ask you all to keep your camera and microphone off during the duration of the event. The WebEx chat is going to be used only for technical issues, and I will ask you to make any questions that you may have or comments in Slido. You'll see the QR code, so you just need to use this QR code and get into the event with the passcode 1632. How are we going to handle the questions and answers? We're going to try and answer, if time allows, the most voted questions. Of course, we will restrict our questions and answers to questions which are directly related with this event. So the event, we will explain later what exactly is the scope and the objectives, but we will also keep a record of these questions. However, the questions will not be answered afterwards in written. Now, yes, and that's my last point. Questions will be answered until the question and answer time is over. If you have unanswered questions that you wish to share with us, please use Ask a Question. The link, we can provide it to you on the chat as well, but it's available on our EFSA websites. I think this is all the housekeeping rules I had for today. And without further ado, I would like to introduce Guillaume Desez. Guillaume is our head of department. He just showed up in the camera. And thank you very much, Guillaume, for making this introduction for us. So the floor is yours.
Thank you, Anna. And good afternoon and a very warm welcome also from my side here in EFSA. My name is Guillaume Desez. I'm the head of the EFSA Risk Assessment Production Department. It's good to see that we have a great interest in this event. Yesterday evening, we counted, we had 446 registrations from 44 different countries in Europe and beyond, representing virtually all our partners and stakeholders in EFSA. We have a very big representation from the private sector, maybe 1/3 of the total number of participants. Then we have a big showing also of the academic world, universities, but also the public research institutes. We have many colleagues from national authorities from within the EU. And then all our other partners and stakeholders are represented, national authorities from outside the EU, international organizations, NGOs, but also other EU institutions and agencies. So a very broad attendance over the full spectrum of partners and stakeholders of EFSA, and this is beautiful to see this. I think that you will agree with us that this event on new genomic techniques comes very timely, because we see that the market is pushing the boundaries of biotechnology every day in Europe and worldwide. The European Commission is preparing a policy initiative which will materialize next year into a new legal framework for plants derived from NGTs in Europe. And we hear it every day. Innovation such as biotechnologies and new genomic techniques are at the center of debate, especially in Europe. Some believe that they are one of the answers to achieve sustainability in our food system. Others perceive more the risks than the benefits. So positions diverge, they are often polarized, and that makes the task of everyone difficult to understand the debate, but even more so for risk manager and policy maker who need to find the right steering. So at EFSA, we look at everything we do through the lens of science, which means that in this NGT debate, we bring the perspective of risk assessment science. We see our role as not to weigh the advantages or disadvantages of biotechnology for society, which we leave this task to the policymaker, and our role is to provide policymaker with scientific advice. And this scientific advice must be based on the best available science. It must be fit for purpose with regard to the question at hand. It must also be delivered when the risk manager and the policymakers need it. And last but not least, we know that to really serve policymakers, scientific advice must also be trusted by citizens. And for all these reasons, openness and dialogue are key values of EFSA. They are actually enshrined in EFSA founding regulation and in all our strategic documents. They feature prominently. The openness and dialogue is at the center of the strategy 2021-2027, which EFSA is entering into. Because once again, we believe this is a prerequisite to develop scientific advice, which will be both based on the best science and trusted by citizens. So this engagement with risk assessment partner and stakeholder is becoming even more crucial nowadays, because we see that the changes are changing ever faster, are happening ever faster, and the complexity is growing, both in the science, but also in society at large. And there is one thing we are convinced of in EFSA, is that we cannot master this complexity alone, and we don't want to master this complexity alone. So on NGTs, as on several other topics, EFSA must ensure that our methodology, which is at the core of the food safety assessment that we deliver, we must ensure that this methodology remains fit for purpose. And that requires that we get all the input and the contribution we need from all the actors of the EU food safety ecosystem. So today, we want to set the scene and promote an open debate with our stakeholders, but also among the EFSA stakeholders. We have distinguished panelists with different roles, competencies, knowledge, and also interest in relation to NGTs. They cover the broad range of EFSA stakeholder, because we believe that connecting this diversity will help us achieve a goal that I'm sure we all share here today, which is that we can provide EU policymakers with the scientific advice and the risk assessment competency that they need. So before closing, I want to once again echo Anna and thank our panelists. Thank you very much for giving us your precious time. We know that your contributions are essential to progress a debate which is of crucial interest for EU citizens. And the number of registered participants is a sure sign of this. You have all seen it, and we see already today 260 participants and still growing, coming online. So I stop here and I thank you all, and I wish everyone a very constructive and fruitful discussion today. Anna, over to you.
Thank you very much, Guillaume. Guillaume, thank you very much for setting the scene and making a very nice introduction to this event. So I would like now to give the floor to the next speakers. And in fact, we're going to have a presentation on the risk assessment of new genomic techniques, an overview of EFSA's recent work. I count for this introduction with my colleague, Nicoletta Papadopoulou. Nicoletta, I think you can turn on your camera. Thank you. And also to our distinguished panel member, Fabien. Fabien? Here he is. And I think just a quick reminder that you can post your questions in the chat and in the chat on the Slido, right? So if I'm correct. And you can and the most popular questions will be addressed first. As I said before, we will restrict our question and answer to the ones which are in the remit of EFSA. And yeah, without nothing else, I'll give the floor to you. I think, Nicole, you're starting first, right?
Yes.
Thank you. Please,
Good
floor is yours.
afternoon. Thank you, Anna. So I will share the presentation. I will start this presentation by giving first a brief overview of EFSA's work on the different techniques, on assessing and reviewing the different techniques that are used to generate genetically modified organisms. And after this brief introduction, I will give the floor to Fabienne Nock, the GMO panel expert, who will explain the different applications that may be used to generate plants by new genomic techniques and the EFSA proposed criteria for their risk assessment. So to the next slide. I think I cannot move the cursor to the next slide. So I will maybe... I'm not sure, Anna, if you see my presentation on the screen. I'm just not able to move forward the slide.
I see the first slide, Nicole. Normally, if you are on a presenter's mode, you should be able to see on your screen some little arrows just below the bottom of the slide.
Yes.
Yeah, there you go. Voila, it's working.
Okay, thank you very much. So, starting with some definitions and the state of the art, genetic engineering is a rapidly evolving field, and therefore Commission over the last decades, together with EFSA and the GMO panel experts, have been assessing the developments of new breeding techniques that were developed from 2012 onwards. Now, with the scientific literature and their applications, these techniques have different characteristics, and within the European Commission report that was published in 2021, they were grouped in two main categories. So two terms that are going to be used here in the talk, and they have been also used in our EFSA documents and the EU report that you might have seen, are the established genomic techniques, otherwise called as EGTs, and the new genomic techniques, NGTs. So to briefly explain what these are and what we mean by these two terms, EGTs are those genomic techniques that have been developed before the adoption of the Directive 2001/18 of the European Commission, and they are characterized by the introduction of a foreign DNA into the plant genome. So far, the GMOs that are authorized in the EU have been developed by established genomic techniques under the Directive 2001/18 and the regulations of 1829 and implementing regulation 503/2013. Instead, new genomic techniques are those techniques that were developed after the adoption of the Directive 2001. Specifically, they have been evolving from 2012 onwards with the establishment of the genome editing, and they will be referred to in this talk as NGTs. So GMOs in Europe, whether they are generated by established genomic techniques or new genomic techniques, they are risk assessed before market authorization by the directives and the regulation, implementing regulation for genetically modified plants 503/2013. EFSA has been developing also guidances respective to this legal framework in order to provide advice to applicants on how to provide structured data sets for harmonized risk assessment of GMOs before market authorization. So EFSA's risk assessment stands on four main pillars that are described in this slide. The molecular characterization, which involves submission of information related to the source of the DNA sequences and the techniques used to introduce them into the plants, as well as the characterization and the prediction of any hazards related to the expression of these inserts, so the newly expressed proteins. There is the comparative analysis that includes the agronomical and the phenotypic assessment and the compositional analysis of the GM plants compared to the non-GM counterparts. There is the food and feed risk assessment, which is the major part of the application, including toxicological allergenicity assessment, dietary exposure and nutritional assessment, as well as the post-market monitoring. And there is the environmental risk assessment, and including horizontal gene transfer from the introduced DNA that could be from any source organism into the environment, as well as post-market environmental monitoring. So these four aspects are used by EFSA to compile the risk assessment with the support of ad hoc experts to the GMO panel, as well as EFSA staff, in order to assess risks, potential risks or hazards to the health of humans, animals, and the environment. Now, going back to my slide, to understand a bit the differences between EGTs and NGTs, I would like to compare some of their main characteristics as well as the techniques that are used, have been used so far. And now, as I mentioned, through a series of EC mandates, EFSA has produced a significant amount of work in different opinions in the last decade, from 2012 until now, describing risk assessment considerations on the plants that are generated by these different techniques. So with regards to established genomic techniques, the main characteristic of the technique is the random integration of any source of DNA. It could be from microorganisms or other plants into the recipient plant. This could be done by direct delivery or by agrobacterium-mediated transformation, which leads to the stable integration of the new DNA into the plant genome. The techniques that are used for established genomic techniques to introduce transgenesis into a plant would also be used to introduce a so-called cisgene or intragene, which is into a recipient plant, and therefore achieve cisgenesis or intragenesis. In this case, since the same technique, so the delivery could be by transformation, since the same technique is used, the hazards related to the introduction, the random integration of such a gene, whether it is a transgene, a cisgene, or an intragene, are similar. With regards to NGTs, a difference that I would like to highlight is the targeted integration instead of random integration. So in this case, using NGTs, such as, for example, the CRISPR-Cas complex, the producer can introduce either transgenesis or cisgenesis or intragenesis into a plant. This means that the foreign DNA, the transgene, from any source organism would be introduced into a specific location in the genome, therefore eliminating the potential unintended insertions by the random integration. Similarly, if a cisgene or intragene is introduced by techniques such as site-directed nucleases, SDN3, choosing the specific location in the genome, the result is a cisgenic or an intragenic plant using not only the NGT to introduce the gene into a specific site location, but the selection of this gene in both cases by EGTs or NGTs comes from the breeder's gene pool, which means it is a gene that would also be used for conventional breeding. What is also new into the category of NGTs is, of course, the plants that can be directly edited. Therefore, there is no introduction of exogenous DNA into the plant, but rather a modification of the plant genome itself without the introduction of a gene from a different source. So in this case, by genome editing, we have a targeted integration of the specific modification for the desired trait that has been used for not only for plants, but could also be used for animals or microorganisms in order to satisfy very specific customer needs. In this way, with genome editing, requirements that are relevant to the interruption of the potential location in the genome or the introduction of the foreign DNA are different compared to EGTs. Now, EFSA has developed different scientific opinions that describe the development and the use of site-directed nucleases 1 and 2 for genome editing, as well as oligonucleotide-directed mutagenesis in order to develop GMOs, as they're all currently included from following the European Court of Justice decision into the regulation for GMOs. So whether the plant is developed by EGT or NGT, in order to achieve an edited plant, transgenesis, cisgenesis or intragenesis, currently EFSA performs the risk assessment according to guidelines and the regulation for GMOs. Now, back in 2012, in its opinion for intragenesis and cisgenesis, EFSA was requested by the European Commission to demonstrate the differences and assess the differences between cisgenesis, intragenesis, and transgenesis. Due to the quick evolution of NGTs, a commission mandated EFSA in 2021 with a new mandate to review the conclusions of its previous opinions following the developments of NGTs and their use for cisgenesis or intragenesis according to the terms of reference that are here on the screen. So EFSA was required to assess if there are new potential risks obtained by cisgenesis and intragenesis by NGTs and EGTs compared to 2012, and to determine whether the existing guidelines are sufficient to assess such plants, if not to propose adaptations. So I will give the floor to Fabienne, who will explain the conclusions of this opinion that went for public consultation in June 2022 and was published in October 2022. To you, Fabienne.
Thank you, Nicole. Thank you for this very nice introduction. So first, before going to the conclusion of this updated GMO panel opinion, I would like to come back on the differences at the molecular level between trans, intra, and cisgenesis. So the main difference is that all the elements used for cisgenesis or intragenesis originate from a crossable plant, which is not the case, of course, for transgenesis. This means that the function that you will bring with the intra or cis gene could have been introgressed in the recipient plant by classical breeding. In addition, for cisgenesis, you will keep the initial structure and thus the regulation element of the initial gene. This is not necessarily the case for intragenic plant, for which the level or the specificity of expression of the gene can be changed. For this reason, the panel concluded in 2012 that in terms of potential unintended effect associated to the function of the newly expressed protein, similar hazard could be associated with cisgenic and conventionally bred plants, and novel hazards could be associated to intragenic or transgenic plants. Next slide, please. So, analysis of the literature since 2012 shows that use of new genomic techniques, such as CRISPR-Cas, for example, could potentially have consequences on the risk assessment of trans, intra, and cisgenic plants, and on potential unintended effects linked to the transformation process. These potential unintended effects correspond to the possible interruption of a gene, the rearrangement of the trans, intra, or cis gene, or the unwanted integration of exogenous DNA elsewhere in the recipient genome. Because new genomic techniques, so the techniques that are there since 2012, permits to potentially target the integration of the transgene or of the cisgene or of the intragene into a specific place in the genome, a so-called safe harbor, it could minimize possible interruption of an endogenous gene. In addition, because integration through new genomic techniques is generally mediated by homologous recombination, it can also minimize rearrangement of the trans, intra, or cis gene during the event of integration. So what new genomic techniques will not change is the possible random integration of piece of the trans, intra, or cis gene or of part of the CRISPR-Cas module used for the insertion into the genome. And this hazard needs to be taken into consideration during the risk assessment of plants obtained using this technology. Of course, one of the challenges here will be to define what can be considered a safe harbor. And for this, the experience gained by EFSA during more than 20 years now of risk assessment and the familiarity gained on GM plants should help. Next slide, please. So to resume the conclusion of the new EFSA opinion of 2022 on cisgenic and intragenic plants, we can say that the conclusion of the 2022 12 opinions on potential unintended effects associated to the function of the newly expressed protein are still correct, meaning that hazard associated to the function of a gene from the gene pool is similar in a cisgenic plant compared to a plant produced by conventional breeding. This cannot be extrapolated directly to intragenic plants, as level or tissue specificity of expression gene can be modified in this case compared to the donor plant. Concerning potential unintended effects associated to the transformation process, the EFSA panel confirms that they are similar for trans, intra, and cisgenic plants when using established genomic techniques, meaning techniques already used before 2012. Considering now the use of new genomic techniques, the ones that were implemented after 2012, for integration of the trans, intra, or cis gene, the panel consider that the risk of interruption of an endogenous gene and rearrangement of the transgene could be minimized. As a general conclusion, the EFSA panel consider that existing guidelines are sufficient and partially applicable for the assessment of cisgenic, intragenic plants, and that on a case-by-case basis, some requirements may not be needed. Next slide, please. So now I would like to present you the second mandate concerning new genomic techniques. So EFSA received this mandate on 28th of April of this year, and the European Commission asked EFSA to give a statement on possible criteria for the risk assessment of plants produced by targeted genesis. This statement was considered at on 30th of September of this year. So just first to clarify a bit what is an EFSA statement. So it is a document addressing an issue of concern, and it is prepared as advice or factual statement for consideration by the European Commission, the European Parliament, the Council of the European Union, the member states, or the stakeholders. The statement of EFSA is prepared normally within a relatively short time frame, which does not permit the establishment of a dedicated working group or the launch of a public consultation. And EFSA may consult the scientific committee, the scientific panel, or an EFSA network during the process of building of this statement. And this is the case for this statement, as EFSA consulted the GMO panel. To establish this statement, EFSA considered the assessment and conclusion published in the previous EFSA scientific opinions on site-directed nucleases, on cisgenesis, on intragenesis, and also on synbio, synthetic biology, that were published between 2012 and 2022. Next slide, please. So before presenting the criteria proposed by EFSA for the risk assessment of plants produced by targeted mutagenesis, cisgenesis, and intragenesis, I would like to come back on the different possible applications of those new genomic techniques that will permit the production of this type of plants, focusing on what can be done with CRISPR-Cas, which is currently the technology the most commonly used for this type of approach. So first, as shown before, CRISPR-Cas can be used for targeted integration of a trans or intra or cis gene into the genome. And this possibility has been already taken into consideration in the new opinion of EFSA on intra and cisgenic plants in 2022. In addition, and this represents the main application probably of new genomic techniques at the moment, CRISPR-Cas and similar tools can be used for targeted modification of an endogenous gene. Next slide, please. So using CRISPR-Cas, one can modify in a targeted way a given gene. The endogenous gene can be totally or partially inactivated through the so-called SDN1 strategy, SDN1 standing for site-directed nuclease 1 strategy, or it can be precisely modified through gene editing or prime editing, and this is called SDN2 for site-directed nuclease 2 strategy. So in both cases, there is no exogenous DNA sequence added to the genome, and the modified version of the endogenous gene correspond to different alleles of this gene. As a result, the pre-existing encoded protein can be inactivated, be modified, or even gain a new function. Next slide, please. So I would like now to highlight an important aspect to be considered here. That is the fact that the modification induced by the new genomic technique strategy, such as CRISPR-Cas, are of the same nature as the ones produced by spontaneous or induced random mutagenesis. This means that if a mutation can be obtained by CRISPR-Cas, this same mutation can be present in the genetic pool of the plant variety that has been gene modified. This means that all the edited plants that can be produced by CRISPR-Cas could, in theory, be obtained by conventional breeding. What CRISPR-Cas does is an acceleration of the process of breeding, and for complex modifications, this acceleration can be very significant, of course. And this should be taken into consideration for the risk assessment of these plants. One of the challenges for me for risk assessment of edited plants will be to take into consideration these two aspects. The fact that the edited plant could potentially be obtained by classical breeding, and the fact that the new genomic technique strategy will accelerate the selection of the plant of interest compared to classical breeding. Next slide, please. So now I would like to present the main output of the proposed statement. That is the list of criteria that EFSA proposed for the risk assessment of intragenic, cisgenic, and edited plants. So EFSA proposed 6 criteria, and I will come back now on these criteria one by one. Next slide, please. So the first criteria for the assessment is whether the genetically modified plant contains or not exogenous DNA. On the next slide, you can see that if the plant has been edited and that it does not contain exogenous DNA, then one can consider that possible unintended effects that could have been generated during the production of this plant are similar to the ones that could happen during classical breeding or induced random mutagenesis. In this case, the plant will be risk assessed based on criteria number 5 and number 6 that I will describe later. Next slide, please. If an exogenous DNA is present in the genome of the plant, the second criteria will be whether or not the gene or the element constitutive of the gene belong to the breeder gene pool. If this is the case, the plant is considered intra or cisgenic, and we'll go to the criteria number 3. If this is not the case, the plant will be risk assessed following existing guidelines used for classical transgenic plants. Of course, one important point here is the definition of the breeder's gene pool. Next slide, please. So criteria number 3 will concern the type of integration of the exogenous DNA. In case of plant transformation through new genomic techniques and targeting of the intra or cis gene in a safe harbor, the plant will be risk assessed based on criteria 5 and 6. Again, here, one of the challenges will be to define correctly what can be considered a safe harbor. Next slide, please. So if the plant has been obtained through an established transformation techniques, meaning the one of the techniques already used before 2012, and that the intra or cis gene has been integrated randomly into the genome, the next criteria will be whether an endogenous gene has been interrupted or not. If this is not the case, the plant will be risk assessed based on criteria 5 and 6. On the next slide, you can see that if an endogenous gene has been interrupted, possible consequence in terms of risk will be assessed. If no risk can be found, again, the intra or cisgenic plant will be risk assessed based on criteria 5 and 6. Next slide, please. On the contrary, if a risk has been identified that would be linked to the interruption of the endogenous gene, then the plant will be risk assessed following existing guidelines that we use generally for this type of plants. Next slide, please. So I would like now to finish to come back on criteria 5 and 6 that are really important ones, of course, and that could be applied to the plants that have been listed here. So criteria 5 concern the history of safe use. I just would like to remind that this concept has always been there since 2001 for risk assessment of GM plants, even if for the plants listed here, this concept could be even more meaningful. Of course, history of safe use will be considered on case-by-case basis and will not always be black or white. And there is, of course, a continuum between plants or gene or alleles that would have an history of safe use and plants or genes or alleles that would not have any history of safe use. So the concept of history of safe use should not be mixed with the concept of familiarity. For example, the fact that the gene belongs to the gene pool, even if the two concepts can sometimes overlap. And in fact, familiarity does not necessarily mean safe, but it could mean that enough is known about the plant to determine the level of safety. Next slide, please. In case the plant and new gene or alleles does not have an history of safe use, the last criteria number 6, will focus on the function and the structure of the new gene or allele, and different questions could be asked at this stage. Like, is the initial function of the modified allele conserved or not? Is there any additional function compared to the original allele before modification? Has the new gene allele the potential to generate a product that may be toxic or allergenic? What is the status of the level and tissue specificity of expression of the new allele compared to the initial one? Of course, these are only examples of possible questions, and these criteria will need to be well defined if considered pertinent. So I have finished the presentation on the different criteria that EFSA propose, and I will now give the floor to Nicole to conclude this presentation.
Thank you, Fabienne. So in order to conclude on the 6 main criteria that you have presented, these criteria have been provided as advice to the European Commission. EFSA is currently not working on another specific mandates on NGTs in plants, but rather the European Commission, supported by these criteria, is working on its ongoing policy initiative. So for us, these criteria are food for thought and also for discussion today. And one of the aspects as highlighted, the history of safe use, would be a key point that probably in the proportionate risk assessment may need to be even more elaborated thought and used. Therefore, EFSA's GMO panel would be willing to continue the discussions and elaborate more on a definition for the history of safe use in the proportionate risk assessment in the near future. Now, these criteria do not indicate data requirements, they do not indicate data sets that should be submitted in applications, and overall, if such applications arrive on our desks as we speak, they would still be assessed following the European Court of Justice ruling of 2018 as other GMOs. Thank you very much. Please stay in touch with EFSA's work on NGTs and other areas, or you may also use the Ask EFSA to send us more of your questions. Thank you, Anna.
Thank you very much, Nicole and Fabienne. I think this was a very clear and interesting presentation, and thank you for keeping the time, which means we would have time to go for the questions that I've seen in Slido have been quite a lot. Greta, I think you're going to put on the slides, present the slides in... Nicole, I think you need to stop sharing, correct? Okay, so all right. So the way we're going to do this, we have about 15 minutes for questions and answers, and I'm going to start directing the questions that you see on the screen, the most voted questions, to our two speakers of this first session. And the first question is, could you provide some insight from the approaches of risk assessment criteria for plants obtained in by genome editing in other parts of the world? Nicole, would you be able to answer to that?
Yes, Anna, thank you. Thank you for this question. Yes, what we hear from other authorities outside Europe and other countries is considerations for genome editing. Of course, the European Court of Justice decision does not apply outside Europe. So their considerations of other authorities are around the evaluation of the so-called risk profile of these plants and applications. A main criteria, such as our criteria 1 on the presence or absence of exogenous DNA, is used to decide whether an application will fall under the GMO risk assessment or will be excluded. In addition, another main consideration is whether the final product could have been achieved also by conventional breeding instead of genetic modification techniques. Therefore, we do see by China, India, and other areas and regions that genome editing or their decision tree is rather used to decide if a genome edited application will fall under GMO or not at all.
Thank you, Nicoletta. I hope it's, Virginie, that this was a good answer to your question. The second question comes related to NGT products being similar to those obtained by conventional breeding. What is the rationale for assessing the safety of one when it's similar to the other? I think I could answer to that, but I will ask Fabienne to address it. Please, Fabienne.
So thank you, Anna. So yeah, it's a very pertinent question, and I think I tried to give you some answers to that in my presentation. So I fully agree that that those plants can be there in the breeding pool and can be used by breeders without this type of techniques. But I think that there is a difference in terms of rapidity of selection of those mutation and level of complexity that you can that you can have in terms of number of alleles that you can associate in the same plant, and I think that we cannot discard this aspect of those new genomic techniques. And I think it would be contradictory to say, okay, CRISPR-Cas is a revolution, and in another way, it's nothing compared to what has been done already. So I think that we have to take into consideration that those plants could be there in the genetic pool, and the data on spontaneous mutation would support this idea. But we cannot say that the breeders would be able to select those plants as easily as he can do now with this type of techniques. So it's really for me the rapidity of selection of those plants that perhaps will challenge a little bit the process that has been used for years now, of more than hundreds of years of selection that had time constraints that for me are not there anymore, and this should be taken into consideration too.
Nicole, I don't know if you want to add anything.
No, Anna, I think that was more than comprehensive.
Maybe I was just thinking that maybe you want to answer, because I think it's on the same line, which is the question about transposons. Fabienne, do you want to follow on that one? And then
I think that it's a very relevant remark too. But again, we cannot say that integration of transposon in genes does nothing to the plant. And for example, the difference between maize and teosint is due to most of the phenotypic difference between those two plants are due to the integration of one transposon. So that means that integration of exogenous DNA close by to a coding gene can have an action on the plant, meaning that this action will be a risk, that there is a risk linked to that. There is a process to go there, and I think that I agree that in many cases integration in an endogenous gene will not lead to a risk. But I can imagine some situation, for example, one gene that controls the expression of another gene, and this gene has the property to be allergenic, for example. Then you could that could lead to a potential risk. Anyway, it's true that looking at this interruption of endogenous genes since more than 20 years now, I think that perhaps EFSA could have a new look at it and a new way to apprehend this question, and perhaps this new mandate could be an opportunity to do that. But I would not say that integration of a exogenous DNA close by to a gene or into a gene will not lead to any modification in the plant metabolism or phenotype.
Thank you, Fabien. Nicole, maybe you could try and address the first question, the concept of history of use and a possible contradiction with the 2012 EFSA opinion. And I think the comment can it be considered proportionate criteria if even conventional plants could not fulfill it?
Thank you, Anna. Yes, so I imagine here by EFSA opinion 2012, we refer to the 2012 opinion on cisgenesis, intragenesis, could be also SDN3. In the case of cisgenesis and intragenesis, or also in our current GMO risk assessment, history of safe use, there is a parameter that we evaluate based on the knowledge for the past safe consumption of the resulting trait.
Oops. Can you still listen to me, Fabien?
Sorry, yeah, I can hear you. Yeah.
Oh, so it's just Nicole that went out.
Okay.
Here she's back. Nicole, you had a little interruption on the connection. I think you have to repeat.
Yes, so whether this gene derives from the breeder's gene pool or not, which means that it can also be used for conventional breeding, it does not mean that necessarily it has a history of safe consumption and known to humans, animals, or familiarity to the environment. So with this respect, criterion 5, that is mostly related to the history of use, aims to understand if there is safe consumption of the final product of the trait and familiarity to the environment before we proceed with additional information that may be needed for the function and the structure of this protein in case this is not there. So I don't think it is contradiction, because using a gene from the breeder's gene pool does not guarantee that it has been previously used in conventional breeding, and therefore such a product exists and has been safely consumed. Fabien, I'm not sure if you would like to also add anything else.
Oh, I fully agree with what you proposed, Nicole.
Okay, I think the next question that I have on the most voted are actually very linked with the same issue, right? I wonder why an edited plant without exogenous DNA must undergo a criteria 5 risk assessment, whereas the same plant created by classical mutagenesis must not. I don't know, Fabien?
Yeah, I think I answered that just before. That the plant that you will have in front of you would be, in some case, very difficult to obtain in such a short time frame for a breeder. So we cannot say that the work of the breeder is nothing. Of course, the breeder are doing many tests and many analyses during the process of breeding. In this case, you can have this allele, this mutation, in a lot more quicker way. So I think this is the justification for the different treatment between classical mutagenesis and edited plants. And to be honest, I don't want to open the Pandora door here, but I think that even for classical mutagenesis, for some traits, I think that perhaps people should ask some question on the safety of some variety when it's very few varieties, but the ones that produce, for example, something that will kill an insect, this type of traits could be studied a bit more in some case to be sure that they are safe, because if this plant is able to kill insects, I would be happy to see what it does on animal cells, on other animal cells. So I think that this is very subtle type of variety, and again, I think that it's mostly a question of timing on the rapidity of production of this edited plant compared to traditional breeding.
Thank you, Fabien. We're still more or less on the same kind of questions, I would say. As many NGT plants will be indistinguishable from conventionally bred plants, would it not be proportionate to use the principles for traditionally bred plants?
Yeah. So I think it's really an important question, obviously. Yeah, I hope I try to answer this. The question about the fact that they are indistinguishable from conventionally bred plants is an interesting one that is not in the remit of EFSA, but it's true that there will be a challenge here to be able to follow those plants and be able to distinguish them from plants obtained by classical breeding. But this is more a risk manager question, of course. And again, I hope that I try at least to convince you that those plants cannot be considered completely equal in terms of potential risk, just due to the rapidity of the production of those plants and the complexity also.
I think we should never forget that in 2018 there was a European Court of Justice decision that contemplated that all these plants produced by what we are now calling new genomic techniques are, in fact, GMOs. What is currently under discussion is it the risk assessment methodology we are following the same appropriate? And I think all EFSA opinions have said that yes, it is applicable. However, there might be in particular cases the need of less data or different ways of approaching. Fabien, please.
Yeah. So yeah, you're fully right, Anna. And I would like also to insist on the fact that all those plants, most of those plants at the moment, with the technology as it is at the moment, will be transformed by an exogenous DNA for the expression of the CRISPR-Cas module, for example. So on this aspect, we cannot consider them exactly as traditionally breeded plants. We need somebody to tell us, okay, there is no exogenous DNA in those plants. That's also a big difference with traditional breeded plants.
Mm-hmm. I think I will give the floor for one more question. And where am I? I think the one on the top right now is, in fact, we've answered already.
Yeah.
And why is the oops? It's changing. What are the risks linked to the rapidity of genome editing?
I think it's not in the rapidity itself, but I think that that during selection, the breeders are applying testing programs on the plant that they are breeding. This can be lengthy steps to arrive to a new variety. And I think that that there is a lot more generation between the first cross that you will do, especially if you imagine a cross, for example, between a cultivated tomato and a wild tomato. You can imagine that there will be many crosses, many back crosses that will not be needed in the case of genome editing. And on this aspect, I think that the process of breeding will be different and will be more lengthy in the traditional breeding compared to those new techniques of genome editing. Saying that, I would insist on the fact that we have to be proportionate, and we have to consider that those plants could exist in the breeder gene pool. So the challenge for us will be to proportionate, to consider this fact, but also take on board the fact that the selection process will be a bit different.
Okay, it's 3 o'clock, and as I said, I think we all need a break. So I would like to again say thank you to Nicole and Fabian Auguet for their presentation, but also thank you to the many questions. As we said, we had thought that it would be a good way to not to tackle the questions which have been most voted. I see that there are many questions which are similar. So I sincerely hope that in the next session we can give voice to everybody by also having our panelists coming from all different areas of interest and with different opinions. And I hope we can do that also with the questions and answers in the next session. So we will restart at 3:10. Thank you very much. Okay, so welcome back. I hope we still have a lot of participants with us. And so thank you very much for the 288 participants that are still with us. We're going to move on to what we consider is the most interesting part of this event, which is really to have an open discussion on the risk assessment challenges for plants developed by new genomic techniques. As we said at the beginning, the discussion should be framed around risk assessment and science, and it's not our intention to discuss options for policy or any of the regulatory or implementation measures that may be needed in the future. So I would invite everybody to refrain posting questions on that direction, because we will not be able to answer to them. What will go on afterwards is a panel discussion with a moderator, Miro. I don't know if Miro can switch on his camera, but he will be moderating the debate and also presenting our panelists, which I take the opportunity to thank from now. And after the discussion with the panel, we will have again 15 minutes for questions and answers, and during that time we will proceed as you've just seen on the first session. I think this is it from my side. So maybe we could just have a look at the panel composition, or I think actually one of my colleagues has posted it on the chats. Okay, and Miro, I will give the floor to you then. Thank you very much, and the floor is yours, please.
Thank you very much, Anna. Good afternoon, everyone. My name is Miro Prik. I am coming from Prospects, and I will be your moderator for the panel discussion, together with my colleague, Magdalena Kufrey, whom you will have the pleasure of meeting in a couple of minutes. Welcome then to the panel discussion. Thank you for taking your time and investing it in being with us, both to the participants in the audience and above all to our distinguished panelists. It is my pleasure now to invite the panelists to come on screen as I will introduce them. We have 7 panelists and I will introduce them in the alphabetical order. First, Dr. Helmut Gaugic from the Environment Agency Austria. Welcome, Helmut. Then Dr. Thomas Jacobs from VIP UGent Center for Plant Systems Biology. Welcome, Thomas. Then Dr. Petra Joras from Euroseeds. Welcome, Petra. Then Professor Jean-Christophe Pagès from Toulouse 3 University. Welcome. Then Dr. Ricarda Steinbrecher from the European Network of Scientists for Social and Environmental Responsibility. Welcome, Ricarda. And Dr. Christoph Thehn from Taste Biotech. We're waiting for Christoph to appear on the screen. Welcome, Christoph. And then Fabien Noguet, whom we met already in the previous session. So once again, very happy to have you with us. Warmly welcome. In order for this discussion to run as smoothly as possible, allow me to draw your attention to the following basic rules. I start with the panelists first. Please provide concise answers respecting each other's time. I will moderate the interactions between panelists and will take care of one important aspect. Everyone will have equal, unfortunately very limited, equal time at your disposal. Panelists who wish to react to somebody else's statement, please raise your hand and wait for the floor. For the audience, you've heard it before, you are invited to post your questions in Slido and to like the ones that you want to see addressed first. Questions will be taken starting from the most voted until the question and answer time is over. I also invite the audience to indicate in your comments if your question is addressed to a specific panelist and to use the thumb up function in Slido to help prioritize the questions. During the panel discussions, polls will be launched to engage with the audience. Participants should keep your mobile phones at hand. However superfluous this instruction may seem to all those who have their hands glued to the phones. Now allow me to introduce my co-moderator, Magdalena, and pass the floor to her to launch the first Slido poll. Magdalena, please.
Thank you, Miro, and welcome to everyone in this panel discussion. We are very much looking forward to the discussion, the debate. But before that, we would also like to give a floor to the audience to understand a little bit more. After what Guillaume said already, we know a little bit more about the different sectors and different stakeholders that are here with us. But now we would also like to learn a little bit more about their expertise when it comes to new genomic techniques. So if I could ask our back-end moderator to give us the slide with the QR code where you can go to the poll to answer one simple question, if that would be possible. Otherwise, of course, you can also go to Slido using the event code NGT and a passcode 1632. And in a moment, we will open a poll for everyone. So you will see if you're already there, there are 2 tabs. One is Q&As, another one is polls. So you can go to polls. It will be open in a moment. But also if we can get a slide with a QR code, that will perhaps be useful for people who are joining us on Slido using their phones. So the poll I see is already open on Slido, and there's just one question, which is, how familiar are you with the differences between new genomic techniques and established techniques developed before 2001? And we have 4 answers there, so please take your time and think about it. whether I am not at all familiar with the differences, I am somewhat familiar with the differences, I am familiar with the differences, or I am fully familiar with the differences. We'll give a little bit more time for the participants to give their answers, and then I will ask our colleagues to also show on the screen the results that will come. And just to explain why are we asking this question, we want to help panelists to better understand what is the level of expertise of the audience here so that they can adapt their language accordingly. So it's mostly for the panelists to make sure that this debate will help the people who are in the audience today and that it's on the right level according to their expertise. So the poll is open now, and I see that the results are also coming up. So I see that 50%, I'll just wait, here we are, 50% of the audience, half of the audience is fully familiar with the differences. That's a lot of expertise on the floor, and also 35% are familiar with the differences, with only a small majority who is somewhat familiar with the differences or is not familiar with the differences at all, which stands at 4% at this point. So I hope that this information will be useful for the panelists, and thank you for the audience for voting. We will have another poll later, which is more topic-based towards the end of the panel debate. But for now, I leave you in the good hands of Miro and with our panelists to learn a little bit more from their different perspectives. Thank you very much.
Thank you very much, Magdalena. It is now time for the opening statements of our panelists. We will ask them to provide their views on the following question. In your view, what are the biggest challenges and opportunities for the risk assessment of plants derived from the new genomic technique? We will start in alphabetical order. Each panelist will have 3 minutes, and I will be the timekeeper. I will be strict and fair, and I will just turn my camera off, and when the last 30 seconds become available, I will switch my camera on again, so this will be a subtle reminder that your time is running out. Let's start. Helmut, what is your opening statement, please?
Yes, thank you very much, Miro, and good morning, good afternoon, dear colleagues, dear participants. Thank you for the opportunity to participate here as a panelist, and thank you for this very scientific and open debate which we are having. I'm working at the Environment Agency Austria, and I'm head of scientific management biodiversity there. So from my perspective, it is very important that we frame this topic in a broad ecological and also ecosystemic perspective, because this is indeed very important also when we discuss the issue of new genomic techniques. And my initial thoughts here are that the range of specific NGT products with different characteristics and therefore also potential risk issues is indeed very broad. We have heard also in the introductory presentations along these lines. Now, from simple point mutations at single and few targeted genomic sites to multiple complex changes in different alleles or also of a different number of different genes and gene families. So it's really a broad range. And these complexities, in my point of view, these complexities of the genetic modification will, of course, and certainly lead also to challenges for the risk assessment. We have to deal with that. The risk assessment of new genomic techniques applications, in my point of view, needs to be conducted following a case-by-case approach, because we have such a broad range and because we have different types of applications here. So I also think that at this stage, no fast-track route to risk determination available for new genomic technique products would be appropriate, as there are no appropriate general denominators of risk or safety available for the whole group of NGTs. This, I think, is also very important. Now, with respect to the comparability of new genomic techniques products, with conventionally bred or conventionally developed plants, I think that they at this stage will be rather limited due to limits on multiple changes, which can be achieved simultaneously with conventional approaches, and also due to the known bias of distribution of spontaneous mutations throughout the genome. That does not mean that we should not look at that, but there is limited possibility to work along these lines. The theoretical assumptions of an overall level of safety for NGT products is not well grounded in these facts. Now, but I also see opportunities, and the opportunities is that there is an ample range of experience with the assessment of GMO products so far, the substantial body of risk assessment guidance, as well as experience with the implementation of such guidance, and we should definitely use that also for the risk assessment of new genomic techniques. This is the opportunity we have because we have a good basis. Thank you.
Thank you very much, Helmut, for breaking the ice. Thomas, may we hear your views on that question, please?
Yeah, sure. Thank you. First, I just want to thank the organizers for giving me the opportunity to come and present today on this panel. In my day-to-day activities, I'm a research scientist, so risk assessment really is quite far away from what I typically do. So it's really great to get this opportunity to wade into that area as well. So as I mentioned, I don't know a whole lot about risk assessment. I'm a scientist first and foremost, and in my lab, we really focus on the technical aspects of delivering these genome editing reagents to plant cells. How to make them more efficient, how to make it easier to use for researchers, how to work at tens or maybe even hundreds of genes at a time. So genome editing is a tool, and in my group, we're the tool makers. We really focus on using this technology because, there's no comparison. It's the easiest and fastest tool that we have in the lab. So research that would have taken us years or decades to perform before can now be accomplished really in the fraction of a time. So we're performing experiments that we never would have thought possible before. Because of this speed and ease at which we can engineer genomes, I think there's a lot of opportunity to use this technology to address climate change issues or other factors for crop growth. I think through genome editing, we can really develop varieties that use less resources, less inputs, so less CO2, less fertilizer, less water. These sort of applications will become possible with genome editing as one of the tools that we use to improve our crop production in the years to come. I think one of the challenges for risk assessment over the next few years will be that there are going to be a lot more applications coming down the line. It probably takes anywhere for 5 to 10 years for a new crop variety to get released to market. CRISPR-Cas tool, the seminal paper, is now about 10 years old. So I think in the next 5 to 10 years, we're going to see a lot more applications of using genome editing in the field. Fortunately, though, this also means there'll be a lot more room for practice, right? With practice makes perfect. We'll be able to see a lot more applications. We'll also have a lot more opportunities to get the regulatory aspect right. I think it's really important that we do understand and get the regulatory aspect correct. So far, there's really been a bit of a log jam in Europe getting these products onto market. But I think that we need to get that moving within Europe for the future. Thank you.
Thank you very much, Thomas, for your opening statement. Petra, could you please share your opening statement with us?
Sure, thanks a lot. And also from my side, hello, and thanks for the kind invitation. Well, I will be representing the seed sector's view on the discussion on risk assessment. And actually, and to be honest, we more or less see challenges, but rather no opportunities in this, specifically in view of the fact that the whole discussion seems to be a bit undifferentiated, although many of the messages coming from the EFSA statements suggest that there are differences between applications and products. We still see that, let's say, the concept of risk assessment is suggested to be applied in a very undifferentiated way.
The main reason why we see those challenges is that it leads to a discrimination of products from NGTs, which are conventional-like, as discussed earlier, and that the efficiency gain which those technologies might bring to conventional breeding or to breeding as such is easily be neutralized by those risk assessment approaches. So that in the end, specifically for those conventional-like NGT products, the investment decision will really be taken in view of is the efficiency gain still there? Are the costs higher than conventional breeding? And then breeders and companies will take a respective decision. And if the whole efficiency gain is neutralized by the regulatory approach, it's probably not competitive in view of investment decisions. I also would like to make the point here that breeding in general is about increasing genetic variation. And as was also already mentioned earlier, these types of increasing genetic variation sometimes also include products which are, let's say, far from what we have on the market today, and this is why breeding is mainly a process of let's say selection and elimination, and this is taken into account also, of course, when we use those new technologies. I would like to make one point on this aspect of speed. I fully agree with Thomas that in research and development, of course, those technologies contribute to speed in view of developing individual characteristics that are used in breeding. But we need to make two distinctions here. If it comes to speed in breeding, we on the one hand need to take into account that with conventional breeding, all this backcross breeding is done to get rid of all the, let's say, foreign genetics which have been introduced by, for example, crossing with wild relatives. While with the targeted approaches, this is not needed anymore. Nevertheless, both are taken into account when testing for the respective trait that has been introduced by those new technologies. So there's no difference in that. And in this view, we have, let's say, some difficulties understanding why, on the one hand, EFSA concludes there are similarities to conventional breeding, while on the other hand, the rapidity or the acceleration is a point for risk assessment here. So now we'll stop here, and we probably go into detail on the criteria later on.
Yes, thank you very much for your opening statement. Jean-Christophe, may we have the pleasure of hearing yours, please?
Yes, thank you, Miro. I'm Jean-Christophe Pagès. I'm an MD, a full professor of biochemistry and cell biology at the University of Toulouse. And I used to be the president of the scientific committee of the HCB, the High Council for Biotechnology. So this is why I thank the organizer to have invited me to share in part my experience on these topics. So I had a very naive reading of the text of the EFSA, and for me it's something which changes quite a lot as compared to what was the rule for the examination and the evaluation. And I think the EFSA proposition is quite open, quite adapted, and it concentrates, as far as I can see it, more on the product than on the process. And if we look at what is probably needed to follow the path of the proposition of evaluation, because it's not a systematic evaluation, it's a proposition of series of examination that propose and finally open to evaluation. And so I would say that I guess most of the questions which are raised, the applicant would have the answer to that and will be able to give a quite clear answer. So if we look at the opportunities and if we compare to what is existing now, I think we have something which is much more proportionate to the risk. And also it's a straightforward approach to the different types, because as was mentioned by Helmut, the spectrum of application is quite broad, and we needed stratification, not to give the same examination to all products. And this is a way to approach this, and I think it's good. It might help to be reactive in terms of adaptation when needed to production of seeds, of goods, and for the society. So I think it's a quite good progress. And finally, the main challenges for me are the velocity for which this different step will be proposed. And so it depends on the type of structure that will be in charge of this evaluation. And also, but we shall discuss again on that, it's the definition of a novel trait, which could be a little bit hard, depending on the type of mutation that are introduced in a specific gene or in a series of genes. Thank you.
Thank you very much, Jean-Christophe, for your opening statement. We now have Ricarda, who is waiting, and we are waiting for your opening statement. Ricarda, please.
Yeah, good morning, everyone. Well, over here in Montreal, it is good morning. And thank you kindly for the invitation today. I'll be taking the floor on behalf of the European Network of Scientists for Social and Environmental Responsibility. So let me start with the challenges. One of the biggest challenges, as I see it, is to avoid being led by or fall prey to assumptions. Another one, and perhaps linked to that one, is to not be fixed or singly focused on the intended modifications and the intended traits, but to ensure that process-induced modifications and effects, as well as other unintended effects, are investigated and fully assessed. After all, these are new genetic techniques. Additionally, targeted mutagenesis is a field of changing and rapidly developing technologies. We do not know what the next NGT techniques of tomorrow will be and the side effects that will come with them. The challenge then is how to fulfill the precautionary principle, especially when faced with intended reduced risk assessment as suggested, and combined with a definition of targeted mutagenesis as broad and as all-encompassing as it is in the current EFSA statement. And what about the risks that I see as the real challenge? The risk assessment of modified plants that live in the wild rather than in highly managed agricultural fields. What about ferns living in forests? What about trees? I mean, compared to agricultural crops, trees are much harder to observe. They have a longer lifespan, sure later spread their pollen and seeds widely. They are exposed to and have to withstand annual and seasonal stresses. How to test and assess the impacts of both intended and unintended modifications. We still have sizable knowledge gaps here, and especially given that trees, particularly woodland or forest trees, are part of intricate networks that we only are starting to understand. So risk assessment needs a full set of reliable data in order to understand what has been altered in an organism and what the effects are or might be, both at the molecular level as well at the interactive level with the environment, or regarding safety for consumption. To prejudge risks simply by broad categorizations based, for example, on technology levels or type of intended trait seems ill-advised. Drought tolerance, for example, is seen as positive by many, but it may lead to invasiveness and loss of vulnerable ecosystems. So a clear opportunity, therefore, here is the tools that we have, and I agree with the tools such as long-read whole genome sequencing or omic tools that are readily available now these days for molecular characterization and assessment. We have a much better ecological understanding of interactions that we can start addressing here with sets of questions and categories. And yes, there is quite a lot of experience and guidance materials out there that we can use. So I feel that there's lots of discussion to be had, and I'm looking forward to it. Thank you.
Thank you very much, Ricarda, for your opening statement. There will be more discussion also as we move to the next opening statement of Christoph. Christoph, please.
Yeah, hello everybody. Thanks for inviting me to this interesting panel and important discussion. I'm talking here for TIS Biotech. Sorry, I have some problem with my voice. I had some infectious disease over the weekend, but I think it's more or less done. But TIS Biotech is following science from the perspective of the protection goals, such as health and the environment. And if there's interest, we also can provide our statement in written form. So NGTs can be used to achieve genomic changes extending far beyond what is known from conventional breeding, compared to the methods of conventional breeding, including random mutagenesis. CRISPR-Cas gene synthesis make it possible to genetically alter the genome to a much greater extent compared to previous breeding methods. Therefore, in depth examination of the intended and the unintended genetic changes will be required in each and every case. But in terms of larger challenges, we also should take a broader picture. What will be a real new challenge is that we have to establish methods and criteria to assess potential interactions between different NGTs events in the environment if released in parallel into a shared receiving environment. Measures need to be established to avoid tipping points in the ecosystems, which might be triggered due to the exposure to a high number of NGT organisms and different NGT traits, which involve many species, which are not adapted by evolutionary processes. I think this is really not the situation so far with the transgenic plants, but will come up, might come up very soon with the new genomic techniques. We will need cutoff criteria to establish, to avoid releases. We need to establish cutoff criteria for risk assessment to avoid releases of NGT organisms into the environment without conclusive risk assessment and to avoid uncontrolled spread in the environment. And these challenges not only concern NGT plants, but other NGT organisms such as insects, soil bacteria, or wildlife species, which all may undergo genetic engineering by NGT technologies in the near future. Against this backdrop, it's no longer sufficient to demonstrate safety to each event, but systemic and combinatorial effects of different NGT organisms within a receiving environment should be taken into account as well. Last remark, similar to the environmental pollution with plastics and chemicals, it's not all an individual NGT GMO which may create the real problems, but rather the sum of diverse effects to the environment. The environmental problems which might be created by the release of NGT GMOs might not only be more diverse and complex, but also may last longer than even those caused by plastics and pesticides. Thus, we have to also consider our responsibility for future generations. Thank you very much.
Thank you very much, Christoph. We also wish you a speedy recovery, and thank you for this opening statement. Fabien, would you share your opening statement with us, please?
Yes, thank you, Miro. So I will try to be short because I had the opportunity to present what I think about the type of risk assessment that could be applied to those NGTs. But like Thomas, I am also a scientist in INRA in Versailles, and I'm working with this type of tools for gene function analysis in model plants in a bryophyte. But yes, I'm also an expert for EFSA, and I have this hat, I think, today. So for me, one of the biggest challenge is to be proportionate, will be to be proportionate. As I say in my presentation, edited plants will not be different from plants obtained by classical breeding. So on this aspect, CRISPR-Cas is not a revolution. And some people could say that these plants should not be risk assessed at all. So again, I think that this would not take into account first the fact that the use of NGT in most of the cases, at least at the moment, involve a step of genetic transformation. And second, the fact that these techniques, again, will accelerate the process of breeding and in some cases lead to plants containing very complex combinations of mutation and traits that could be in some cases very difficult to obtain by classical breeding, even using techniques like marker-assisted selection, which was already a step forward in the technology to be able to associate multiple allele of interest in a given plant. But I really think that NGT go a step further on this aspect. So concerning the practical challenges for risk assessment of these plants, I think that defining the history of safe use and applying this concept efficiently is one of the challenges. Defining what is the breeder's gene pool and how to use the concept of familiarity are also challenging aspects for future risk assessment of NGT plants. This doesn't mean that demonstration of safety of an edited plant should be complicated or lengthy. This should be convincing. And finally, if we consider the concept of safe by design, I see here an opportunity for a more proactive way for risk assessment that would anticipate what could be asked or part of it for a given edited plant before this plant has been produced. And on this aspect, again, NGTs are a bit different compared to classical breeding. And I will stop here.
Thank you very much, Fabien. So the opening statements are behind us, and they have shown a variety of views and the richness of ideas, approaches. I'm happy that we are able to continue with the questions, namely the first question, which is also related to what we have just heard an hour ago. EFSA has developed criteria for the risk assessment of plants derived from new genomic techniques. And the question is, what are your views on these criteria? So what are your views on the criteria that EFSA has developed? And here we would go in a slightly different order. We would take the question from the reverse alphabetical order. So those who were previously the last would now be the first. And everyone would have 2 minutes to provide an answer to this question. And then if you want to, you have the possibility of additional minute to comment on what one of the other panelists has said. So first, a round of responses to the questions, and then 1 minute for comments, if you wish to do so. I'll just repeat the question that the audience can also see on the slides. What are your views on the criteria that EFSA has developed for the risk assessment of plants derived from new genomic techniques? And here I would invite Christophe again to take the floor.
Still the same voice. So in the statement as published, EFSA raises the impression that in most cases, mainly SDN1, site-directed nucleases 1, there would be no need to take unintended genetic changes caused by the NGT processes into account. It looks like EFSA is assuming that the unintended genetic changes and the associated risks could not be distinguished from those resulting of conventional breeding. If this would be accepted, if unintended genetic changes would no longer be taken into account during risk assessment, the proposal made by EFSA would lead to a substantial lowering of current standards for risk assessment, leading to a partial de facto deregulation. We think, or we come to the conclusion, or we have the impression, so to say, that the assumptions of EFSA are largely caused by inadequate data. In the context of his previous opinions, the authority has stated several times that it did not have the mandate to comprehensively assess all relevant scientific publications regarding unintended effects caused by NGT processes. And now, today we published a report, a backgrounder. It took us some time to double check. And indeed, it looks like EFSA has overlooked most of the relevant publications. And even if some publications were listed by the EFSA opinions, none of these publications were addressed in the report to systematically examine unintended effects caused by the NGT procedures. So we think from this background that the criteria proposed by EFSA should be reworked. There should be first an assessment of the unintended effects, which regards their relevant for risk assessment, and then we might have further discussions. But currently, this statement is published is not sufficiently backed by science. Thank you very much.
Thank you very much, Christoph, for your response to this first question. Ricarda, your turn now, please.
Thank you kindly. Yeah, for me and for us, the criteria look overly minimal, both with regards to depth as in range, and are not fully covering the spectrum of concerns. The first four are supposed, as I can see it, to deal with the molecular characterization of the genetic modifications introduced into the plant, but there are very little requirements for any actual data, be that long-read whole genome sequencing, gene expression profiles, or unintended modifications and their effects, unless they are meant to be later in criteria 6, but that is almost circumventable. So it also appears that counter to what seems to be implied in the EFSA statement, it needs to be emphasized that GMOs are neither defined by the presence of so-called foreign DNA, nor are risks limited to the presence of foreign DNA. Yet that is the category that is put aside as full risk assessment, and the rest wouldn't. So it's not only foreign DNA that holds risks and that can therefore be singled out. For example, small point mutations, depending on where they are placed, can result in the enhanced presence of allergens or toxins, can limit root growth or disrupt communication networks. And also, what about the size of mutation? It also doesn't say anything. As one cannot assume safety simply by the fact that an intended or unintended mutations may be small, or for example, that it may be present in an overly wide defined breeder's gene pool. That doesn't make them safe either. And that has been said before in a statement, but it is not in what we can read here. I mean, it had been said in contributions earlier, but in the EFSA statement, it's not there. We shouldn't forget plants have, for example, many defense genes and networks, and it depends on context within other genes and regulatory sequences, or the disruptions, whether toxins are produced and to which extent. So it is not just about the gene or like a modification, but context. And an overly wide gene pool does not allow for context. In any case, one would need to show that these genes do exist in the wider gene pool and also that they are safe there. And then one needs still to test that they are safe where they are placed. I find that some terms are defined in a way that remains rather unclear, making it impossible to fully comprehend or analyze the proposal. These include terms like not defined, like safe harbor targeting, risk profiles, history of safe use is not properly defined, environmental familiarity, extremely wide definition, as mentioned before, of targeted mutagenesis. So I find that I would have liked to see also the precautionary principle really underlined here, and that is not the case. Let's see what happens next.
Yeah, thank you very much, Ricarda. I have already counted your intervention as a response plus a comment. And I would like to now invite Jean-Christophe to provide your answer to the question in the 2 minutes that follow, please.
Thank you, Miro. So for me, criteria 1 to 4 are straightforward and quite clear, and they respond to the expectations, which is, I insist on that, not to evaluate the product by itself, but whether it needs or not an evaluation and what type of evaluation. Second point is criterion 5, which is a little bit more perhaps difficult to precise because it overlaps new mutations and existing mutations. And I think it needs clarifications just to say that every type of mutation which could arise naturally are covered by existing or already possible trait or allele that would be introduced. I mean that in the HCB we have clearly remind when we did our evaluation of these new techniques, that the fact that on a biochemical point of view, you cannot distinguish any types of mutation depending on the age, and so they are covered. And in fact, targeted mutagenesis is just a technique which is a technique of mutations. It does not anything else that does not the classical techniques. So it's quite clear. Finally, just to comment briefly on what was said, I think the foreign DNA and of target and other modification of the genome are covered and are considered in the examination process that is proposed, and that all the criteria are quite clear. They need to be on a case-by-case analysis reevaluated for each product, but they are by themselves quite clear. Thank you.
Thank you very much, Jean-Christophe, for the answer and the comments. We now move to Petra to ask you if you could take the floor, please.
Yes, thanks a lot. I would like to start with a general point. I mean, the Commission asked EFSA to do this or to provide this technical advice under the General Food Law, and without specifically referring to the current GMO framework. And nevertheless, we have the impression that the whole, let's say, mindset behind these risk criteria are really purely from a process-based angle, without really considering the product and also the importance of the similarity of the outcomes of to conventional breeding. We support the conclusions from EFSA that the certain plants obtained by targeted mutagenesis and cisgenesis do actually not pose new hazards compared to plants developed by conventional breeding. But nevertheless, when we look at the criteria that have been proposed, they are applied rather independent of this assessment of the risk profile. So this would actually then in the end discriminate conventional-like products against those resulting from conventional breeding. Specifically, criteria 5 and 6 use terms that to us are open to interpretation, and which would not allow a breeder to really determine if in the end a certain product concept he is thinking of developing would be covered by those criteria. And for industry, it's really essential to have a framework that is clear and use unambiguous criteria, so that companies in the end know what regulatory requirements are applicable to their products, not only in view of requirements, but also, of course, costs, timelines, etc., and that rather influences, of course, investment decisions. in order to assess the risk profile of an NGT plant and if it has comparable risks to conventional breeding, we would suggest a pre-assessment, maybe based on similar criteria as proposed by EFSA and with criteria 1 to 4, but maybe a bit more concrete, really looking at the method that has been used. If there were transgenic intermediate steps, for example, which has been touched upon also by other panelists, the confirmation of absence of transgenic DNA, of course, is important. But then also just have a look at the intended genetic change and then also describe the resulting phenotype. So this should be sufficient in order to assess if a product has a conventional like risk profile, and with this could also be regulated as a conventional product without further history of safe use assessment. Thanks.
Thank you very much, Petra, for your answer and the comments on what has been said previously. Thomas, would you share with us your view on the question and possibly your comments?
Yeah, sure. So first, I would also echo what we just heard, that I agree with the background statement from EFSA that genome editing would not pose any new hazards compared to other existing technologies. So yeah, I fully support that as well. However, reading through the text and coming from a very technical background, I find the definitions of the report very challenging to read. I think the criteria are rather imprecise. There are a lot of genome editing technologies that don't clearly fit in any one of the particular categories. We saw that earlier in the first session on the slides, like SDN2-like. That's not currently in the text, but clearly there's a slight modification to those technologies that make them not quite like SDN2, not quite like the others. I think we're going to see more and more of those types of technologies as the field advances. So with this sort of imprecise terminology, it's not really future-proof. And I see the problem with this is that these criteria could be interpreted in many different ways. So it's hard to know, what it is that a company would need to submit in an application. I think this can lead to a lot of different confusion. I also don't see how a clear recommendation could be made using such vague, imprecise terminology. Many of these criteria, and in particular the last 4, so is it 3 through 6, I don't see how they're specific to genetic engineering itself. For instance, typical plant breeding, you could ask the very same questions. How was that resistance allele integrated into the genome? Were there other genes that were brought along with it? What do those do in the genome? Do they have a history of safe use, and so on? Yeah, I'll stop there.
Thank you very much, Thomas. Helmut, what is your answer to the question, and what are your possible comments to what has been just said, please?
Thank you very much, Miro, and thank you for the question. I see this as a stepwise approach, and in this context, I would like to thank EFSA for providing this statement and for providing a proposal for these criteria. We face a broad and complex issue here, as we have been discussing, and in these cases, it is in most cases good to have a proposal on how to approach this in a structured manner. And criteria are always a good possibility to get some structure into the subject. So we see this as a starting point, but we also see a lot of challenges and a lot of need for further refinement to strike the balance of having criteria and having clarity on the one hand, but at the same time not oversimplifying the subject by giving the impression that if you have a decision tree or a few criteria, the resulting questions will be easily answered. But we think that can be done in a step-by-step process with subsequent discussion. For example, by further developing the criteria with respect to also how a concrete risk assessment then would need to be done. and not only have criteria for the differentiation. We also see possibilities to further develop criteria with respect to the assessment of unintended and off-target changes genetically linked with the intended trait. This is currently also quite disregarded, and we think that this is an omission and should be further developed. So issues such as breeders' gene pool definition, safe harbor definition need further clarification, and we also see the biggest challenge in further developing criteria 5 and 6. With respect to the history of use, we have a subsequent question, so I will address this later. Thank you.
Thank you very much, Helmut, for your response, and you will have the possibility to provide comments on other aspects of the responses. It is now Fabien's turn to provide some insights.
Yeah, thank you, Miro. Again, I will be quick because I had the opportunity to present what I think about those criteria. I think it's a bit symptomatic to see that we've got extreme position here. When people look at what we propose, people think that we go too far in terms of history of safe use or analyzing the product that will be brought by this genome editing, and some other people think that that we are too light on the aspect of unintended effects. So you see the difficulty for EFSA to be able to find the correct position here. So of course I have been solicited like all the experts of the GMO panel for the elaboration by EFSA of these criteria. So of course I have the feeling that they are justified, but I'm also aware that that they are just criteria, and I think that many of your comments comes perhaps a little bit too soon in the process. They are just criteria, and we have a lot of work. Will be needed to be able to use these criteria if they should one day be the basis of future guidelines, for example, for gene-edited plants. So again, I reinforce the fact that they are just criteria. They are not guidance. They are not an opinion. Just to come back on the question about off-target. So in previous opinion, EFSA already addressed this question of off-target effect and conclude that if there was off-target produced in the recipient plant, these would be fewer than those occurring, of course, with most mutagenesis techniques. When you mutagenize a tomato plant, for example, with EMS, you will have more than 600 mutations in this plant. This is nothing compared to what can be produced by a CRISPR-Cas system. And furthermore, when those changes occur, they are of the same type, again, as those produced by conventional breeding techniques and spontaneous mutations. So even when we think about possible off-target that would be linked to the modification, genetically linked, you don't have any way to demonstrate that this is due to the CRISPR-Cas system and not due to spontaneous mutation. So here I think that there is an issue on this type of demand. So I think I will stop here, Miro.
Thank you very much, Fabien. This now leaves us some time to hear comments from those who want to comment. And I saw that Christophe didn't use the time, also Helmut, Thomas, and Petra. So you have the priority for 1 minute commenting what has been said before. And then if there's still some time, everybody else will also be able to express their views. I see Christophe has raised the hand. Please, Christophe.
Thank you very much. It's just in regard to what I've heard about of mutations and the type of mutations. Of course, we agree that the number of mutations might be higher, but the site of the mutation and the combination of the mutations might be completely different if NGTs are used. So it needs to be developed, an assessment, to make a distinction between those mutations which are likely to occur by random mutagenesis, for example, and those which are unlikely. And we gave you some ideas how to develop this, to start with the potential of NGTs to insert or to introduce genetic changes in sites in the genome where they normally would be highly unlikely, or under conventional breeding, would be unlikely to occur, or not only the intended, but also the unintended effects. And as long as you do not your homework, you cannot just come back and say it's the number of mutations which is lower, because in the end, it's the biological effects those mutations will have. So you have to first assess the intended and unintended effects, and then go to the effects, direct, indirect, delayed, or accumulated. And if you're not doing this homework case by case, you will not be able finally to give a conclusive answer to the safety of the products. We don't think all these products are dangerous per se, but you have to do your homework to come to a conclusion which is really based on science and answer the question, demonstrate safety as it is currently required. Thank you very much.
Thank you very much, Christoph. Do we have anybody else who would like to comment on what has been said in this round of answering the question? We've heard many interesting statements. The other possibility for us is to move on to the next question. Helmut raised the hand. Please, Helmut.
Thank you, Miro. But I saw that Petra and Thomas, I think, were first, so I don't want to skip the line. But sorry, I don't want to interfere with your moderation, of course.
Thank you very much, Helmut. I didn't see it because it's on a very bright background. Thank you for telling me, Petra, Thomas, and then Helmut. Thank you, Helmut. Petra, please.
Thanks a lot. I would again like to bring in, let's say, the breeder's perspective here. We're talking about individual mutations, potential off targets, but this is something which is very common in classical breeding or conventional breeding as well. And this is why those plants are in the end also tested in the field, and not only NGT plants, but all plants, all varieties which come to the market are tested in the field. And they are also tested for potential, let's say, off phenotypes, because a breeder will never put a product on the market that doesn't perform according to expectations. So it's a holistic view that is taken. Plants are tested in different environments, and that in the end allows an assessment of the performance and if it meets expectation, and if there are no, let's say, off phenotypes that should be discarded. In that sense, I would just bring this perspective again, and again highlight that this is not different to conventional breeding, and we should take an approach that doesn't discriminate conventional like NGT plants.
Thank you very much, Petra. Thomas, your turn, please.
Yeah, thank you. I just wanted to add one comment. Looking at a lot of DNA repair profiles in the lab, I can tell you that everything is possible with DNA repair. So if you want to try to make a distinction between natural or induced, I think that would be a very challenging endeavor to do. Also, just to point out the fact that with a lot of sexually propagated species, if off targets are made somewhere else in the genome, they would be crossed away once the materials are handed to the breeders, and they further that on. So for asexual species, okay, that's a different discussion, but for at least for sexually propagated species, I think it's less of an issue.
Okay, thank you very much, Thomas. We now have Helmut, who also asked for floor.
Yes.
Helmut, please.
Thank you very much, Miro. Just two brief comments or observations from my side at this stage. I think it is very important to combine the experience of breeders with the necessary requirement to approach the risk assessment issue from a human health and environmental perspective. I think this combination is extremely important to move us forward here. And with respect to the risk assessment, I would like to confirm, also to support from my side what we have heard before, that we have to address the complexity of the issue and to look always on the context. The genetic modifications are important, of course, as a molecular characterization is a very important point in the risk assessment, but let us look at the plant in the context of its receiving environment and what it does there. This would be a truly ecological approach, which I support. Thank you.
Thank you very much, Helmut. I see that Ricarda also wants to make a comment, a final one, before we move to the next question. Please, Ricarda.
No, I think now my mic is on. Thank you very much. Just a brief comment, and I fully agree with Thomas that there is just a whole spectrum of different repair mechanisms at play within cells. The interesting part, of course, is here that CRISPR has actually found a way to circumvent that, to keep insisting to set the mutation rather than letting it be repaired properly as it was before. So we have a different situation here. And the other one is that we are also at the beginning of understanding really like the side effect of mutations, such as what we thought until now was silent mutations. And now we understand that a lot of them, despite not even giving rise to a different protein, but they give rise to other negative effects due to regulatory, that's assumed due to regulatory issues. So we have a lot of it is thanks to CRISPR. We have a lot of new information, and we have to change our understanding due to that. But that means even more, we need the precautionary principle here and really do a proper risk assessment, as this is new territory.
Thank you very much for your responses to the first question and for briefly commenting on what the colleagues have said. We now move to the second question, which is that the EFSA statement mentions history of use as a key aspect in risk assessment. How would you define the history of use? And while you are reflecting on that question, I would just like to explain that we will proceed in almost the same way as before. 2 minutes for a statement, 1 minute for a comment. And the order in which we will hear you would be, will just follow the expression of interest. As you raise your virtual hand, I will give you the floor. So maybe I repeat the question once more. The EFSA statement mentions history of use as a key aspect in risk assessment. How would you define history of use? Who would like to start? I'm looking intensely not to overlook a hand. Jean-Christophe, please, Jean-Christophe. You're muted, it seems. Jean-Christophe, you are on mute, it seems.
Yeah, excuse me. Yes, thank you. I said someone has to start. So rather than the definition of the history of use, I guess it's more important to define what it's new. Because as it was mentioned by Fabien, by Thomas, by Petra, and by all the scientific community, all the variation could arise in a plant. And so all types of mutation, they exist. They are not always selected, but they exist in a way. And we do not have concern with that because we consume plants having a series of mutation we don't know with no trouble. The thing is, and it is one of the interests of this targeted technique, is to promote evolution and sometimes to change the function of a gene. And that Perhaps we don't know, and that need examination. And the rest is the background of variation. We are all different. Life is mutation. With no mutation, there is no life. 3 billion years ago, without any mutations, we won't be there. So what we need is to try to look at what is really new, and then I think we would have a good framework for examination, proportionate and fit to purpose. Thank you.
Thank you very much, Jean-Christophe, for breaking the ice for this third question. Who would like to continue? We have Helmut. Helmut, please, the floor is yours.
Thank you, Miro. And along the same lines as Jean-Christophe kicked this discussion off, I would like to say that I think I mentioned already that criteria 5 and 6 are particularly challenging. And rather than suggesting a definition of history of use from my side, I would also like to share a few reflections which go in a similar direction. We need to look at what is new, basically. I observe that we have history of use, we have history of safe use, we have familiarity, and it was rightly pointed out that these are not similar concepts, but there are some differences, but they are still not very clear, at least to me. So if we would continue along these lines, quite some further work would be needed. And it would need to be work on a scientific basis. That I think is very important. The history of use should be defined based on a specific comparison of the new genomic technique plant with plant lines with similar traits and comparable genetics, which were used in agricultural practice for similar purposes as the newly developed NGT plant. I think that's very important that we keep to that. Quite theoretical assumptions of comparability between an NGT product and plant that might occur in nature cannot be a substitute, I think, for a case-by-case assessment based on evidence from this practical use. So the consideration of the possible occurrence of a trait in the breeder's gene pool as such will be of rather limited value at this stage. It is important basic information, but it doesn't move us much further. Rather than that, specific information concerning the functions and the effects of a gene or a gene combination underlying a trait is needed for the assessment. I'm thankful to EFSA again that they put forward the suggestion, but it needs quite a lot of further work. Thank you.
Thank you very much, Helmut, for this contribution. Anybody else who would like to continue the discussion, sharing your views? We have three. I didn't see the exact order. We will leave Fabien for the end, and we continue with Christophe, then Thomas, and Petra. Please, Christophe.
Thank you very much. So I would like to add the aspect that in the context of biology, the concept of history of use, or as you also framed it before, history of safe use, not only use, but safe use, should take into account evolutionary dimensions, processes, and mechanisms. From this perspective, genomic techniques that can escape the boundaries of species and the natural mechanisms of genome organization cannot be considered as having a history of safe use. In regard to the gene pool, this may offer interesting insight for potential future traits. However, as the example of the de novo domesticated tomato shows, which also was assessed by EFSA, it's the context of the genetic variations within the genomic background that can largely impact the outcome and safety of these applications. So the gene pool as such is not a valid concept. NGT processes allow new combinations and new gene variants within the gene pool that are unlikely to result from conventional breeding, new genotypes, which which are not likely to occur from methods of conventional breeding in regard to intended and unintended effects. So I would agree we have to find out what is really new in regard to these unintended effects, but this really needs to be sorted out and answered comprehensively before we can go further on with the discussion about future risk assessment of NGT organisms. And so far, this answer was not investigated and it is not answered. Thank you very much.
Thank you very much, Christoph. Thomas, it's your turn, please.
Yeah, sure. Thank you. So the history of use, I really had difficulty appreciating this, reading the text, what it was exactly trying to get at. So I really don't know how to answer exactly how I would define history of use. To me, it seems like it's not really a genetic engineering specific definition. History of use, you could easily apply this to what we call conventional plant breeding. If you bring in a new variety, as Fabian mentioned in the first half, if you bring in a resistance allele that is somehow toxic to a pest, and what is the toxicity of that to animal cells? That question is never asked in conventional breeding, but for some reason it gets initiated within genetic engineering. So I find that a bit confusing why you would apply these standards to one type versus the other, because we're already past that. The modification has been made. We have a bag of seed. We want to evaluate what is occurring in that plant. How that plant got made doesn't really matter anymore. What matters is how that plant is performing. So for me, I don't see this as a genetic engineering question. Just I don't think it belongs in the GE terminology. Thank you.
Thank you very much, Thomas. Petra was next. Petra.
Yes, thanks a lot. I fully agree with what has been said in view of the novelty, which is really needs to be identified here. So because the starting point, I think, for a history of safe use is always the recognition that the traditional crops have been consumed for generations and have a history of safe consumption here. And so in view of plant breeding, the aim is always to create diversity and also using crop wild relatives, for example, to do so. And then, as Thomas just said, you could ask the same questions to conventional breeding. And there are many examples of varieties which are used in agriculture that have a history of breeding with crop wild relatives who have never been a history of safe use in consumption in Europe. So there are measures and safeguards in conventional breeding that allow to control this breeding with also genetics which don't have a history of safe use and in the end come up with products which are safe on the market. So again, comparison with conventional breeding and only make a specific assessment if there's really a difference. And we acknowledge that EFSA has come forward already with a conclusion in 2012 on the concept of history of safe use when it comes to plant breeding, and they acknowledge that there is probably a difficulty with applying this concept which has been developed for food to plant breeding when varieties which are on the market and are commonly on the market only for a few years could never achieve a history of safe use, as for example mentioned, of 25 years. So it should be rather a general concept here and not addressing individual genetic changes, but really the crop and its history of safe use in Europe.
Thank you very much, Petra, for your contribution. We now have Ricarda, who hasn't spoken yet, please.
Thank you kindly. Oh, my phone starts ringing in the hotel room. I apologize. Just
maybe we have the time to make a comment, if anybody wants to make a comment on what has been said in the meantime. Now Ricardo is back, so take your time and...
Real sorry about that.
No problem. Floor is yours.
Concerning history of safe use, I feel like many have said, like, firstly, it is not well defined and would really need a lot of work to make it helpful in this context. I find it helpful to think in terms of comparators that one can much better directly relate to and compare, a little bit in line like what was before in the current form of risk assessment, to have a close relative. I mean, they have a line, a close line, if not an isogenic line, and I can see the problem, of course, with trying to understand what the differences are. And I think what's the novelties, if one wants to use that term, or what is it we really need to assess here? And that will still, I think, require quite a lot of more work and understanding as there's more NGTs coming into the pipeline to be assessed. So we will learn in that process as well. But given the hopes that are voiced to go along with this technology, I think it is very important that we are getting it right, that we are not sort of missing important steps in the risk assessment that later we will regret. But also we want to trust them. And so if there is no trust in the risk assessment, they will also not be helpful. So in a way, we need to work on that concept much more. And I found difficult in the EFSA statement that it seemed that point 5 was the major point in it. And only if it wasn't fulfilled would one sort of go on to point number 6, which I do not find correct. And I mean, we need a full assessment, and maybe the understanding of comparators can help form a picture, but it should not be a criterion for decision making.
Thank you very much, Ricardo, for your intervention, which brings us to the end of these various 3 turns of discussion. So I would really like to thank you for being scientifically exact and precise when it comes to timing as well. And it is now time to let our audience, the participants, speak and talk to you, talk to us. So I'm very happy to say thank you for these rounds of discussions, of statements, and happy to ask my colleague Magdalena to take the floor and guide us through the next step. Please, Magdalena.
Thank you, Miro. It was a pleasure listening to this very, very interesting discussion in the background. And now we would like to give a platform also for our wonderful audience that stayed with us until this moment. And before we move to Slido, where there are a lot of interesting questions waiting for you, we would like to do a little concluding poll in which we would like to ask the audience, after what you have heard today during this debate, during this discussion, what is your opinion about the different scientific requirements for the risk assessment of plants derived from NGTs compared to plants derived from EGTs. So I will ask you to go to Slido. I think that many of you are already there. You can use the NGT hashtag and then the passcode 1632. Or if you prefer, you can also use the QR code. And then otherwise, you can also go to a poll that is already waiting there for you. And I would like you to answer this question after what you have heard today. If you could let us know, should there be different scientific requirements for the risk assessment of plants derived from NGTs compared to plants derived from EGTs? And we have 4 answers here. So answer number 1 is no, the requirements should stay exactly the same. B, yes, the requirements for NGTs should be stricter. Or perhaps C, yes, the requirements for NGTs should be less strict. And the answer D is, I don't know, I still have to reflect on that. I perhaps don't have my opinion ready at this point. So I will ask you to vote, and I see that people are slowly starting to vote. I will just give you a few more minutes to make sure that everyone had a time to reply. And then I'll just wait a little bit longer to make sure everyone managed to vote. And I see that the results are already coming. So let's see until we can see it here on the screen. And I see that the vast majority, over 70% of stakeholders that are here today with us, say yes, the requirements should be less strict compared for NGTs compared to plants derived from EGTs. I also see it's still changing as more people are voting, but I think the differences won't be very big. I see around 20%, 18 right now, saying the requirements should stay the same. So there shouldn't be any changes in the requirements as they stand today. And also around 10%, 9% at this moment says yes, the requirements for NGTs should be stricter. I also see that only a very, very small minority, around 5% of stakeholders that are present here today, still don't know whether the requirements should be stricter or less strict, or should they remain the same. So I think that through this discussion, and perhaps also through the background research and information that the stakeholders already gathered before, they already have quite strong or they have opinions about this subject. Just to let you know a little bit more why we are asking you this question, it's of course also to give the idea for the panelists who was in the audience and what are the thoughts after this discussion, but also for the EFSA to have a glimpse on what the stakeholders that are present here think about risk assessment of plants derived by NGT and the scientific requirements that are needed. So thank you all that were voting. As you see, we're trying to also, I know that there's not a lot of time, and there are many people joining us today. The debate took quite a lot of time, but via the small polls, we also try to harvest the opinions from the people that are here with us, and also those that perhaps didn't ask their questions or didn't have or won't have a chance their questions to be answered, because we will only cover as many as we can today. So with this, I would like to close the poll and move to the questions that arrived on Slido in the meantime. So if you could please share the screen with us so we can see the questions as they stand. And then we'll just go one by one, looking at those that were the most voted. And here also a little reminder that for the purpose of this event, we'll only take questions that refer to the scientific risk assessment and science-based questions. We are not going to talk about regulations, because that goes beyond the scope of this event and also mandate of EFSA. So unfortunately, or fortunately, the questions that will be about regulations will not be in the scope of the Q&As in this session. And having said that, I will just quickly go to the first question that arrived, which is: targeted mutagenesis for NGTs is fast and efficient. Products need to be risk assessed. Random mutagenesis is random, therefore, and exempt. Is random better than targeted? Looking at this question, I also see maybe one thing that I should mention is, if any of the panelists would like to answer any of those questions, I would like you to put your hand up so we see who would like to take this question. And as I said, questions about regulations will not be taken since this is not in the scope of this event. I saw that Christoph was the first one to put his hand up, so I'll allow you to take this question. Please go ahead.
Thank you very much. So this is a question we often are asked in our work, and for us, the random mutagenesis only produces genetic variations in the genome, which you could expect also from natural processes, but within a shorter period of time. And NGT can do more. NGT can also introduce gene combinations and gene combinations and genome changes at sites which are unlikely to occur in nature and conventional breeding, at least within a reasonable period of time is given. So if you agree that NGT can do more than conventional breeding, you have also to be aware that this technology needs to be regulated in terms of intended and unintended effects. It's a simple conclusion, and EFSA still has to do some work to develop methodology and criteria to find out what is really new with NGTs in regard to intended and unintended effects. I think there's some work still has to be done. Thank you very much.
Thank you, Christoph, for this very short answer. I very much appreciate, because that will allow us to take more questions during this session. Usually what we'll do is I'll just have one question, one answer from a panelist, but still, since I see that this is a question where there will be, again, very different opinions, I will also allow Petra and then Fabienne to take a floor, and then we're going to move to the next question. So Petra, please, the floor is yours.
Yes, thank you. I think it's a very important question, and actually it shows that we need to take a differentiated approach here. On the one hand, we have those products which are similar, so meaning targeted mutagenesis and cisgenesis and random mutagenesis cannot be distinguished, and the kind of products are the same. And we might also see products which are a bit more advanced, like Christoph just said. So I think a one-fits-all approach is just not suitable here. We need a differentiated approach, and we need to draw the lines correctly in order to not discriminate conventional-like products which are already on the market, and then those new technologies also will, let's say, contribute to what we expect them to do.
Perfect. Thank you, Petra. Also, thank you for a brief reply. And now I will give floor to Fabienne, and then we'll move to the next question.
Yes, so very quickly, I think that that random mutagenesis, in terms of efficiency of creating new diversity and new alleles, is really close to classical breeding and has nothing to do with the efficiency and speed of the technology of genome editing. And for me, that's why it's justified to have a better look at those plants compared to random mutagenesis. Also, in terms of complexity, as Thomas said before, you can imagine that you will modify hundreds of genes in a given plant. So all those parameters, the interaction between the different alleles that you have produced, this, I think, could deserve, in some case, a better look compared to random mutagenesis.
Perfect. Thank you, Fabienne, for this reply. I hope this clears up the question. And as we saw, there were, again, different perspectives. I'm going to move to question number 2, second most voted question, which says, why are the EU, the European Union, increasing the regulations of these technologies when GMOs have a 25 years of history of safe use? I am afraid that this is all albeit an interesting question, not a question that we can address here with those panelists, since this is a specifically question about the reasons of the European Union, and that goes beyond the merit of EFSA, that is here to provide scientific advice and have a science-based discussion. So I will discard this question for now, and perhaps there will be other platforms in the future to ask those specific questions to other stakeholders. I'm going to the third question that arrived with 22 votes. If we demand a risk assessment on edited plants without exogenous DNA, looking for changes in for example, expression of genes, I do not see the difference to the regulation in place. I assume that this is more a comment than a question. So thank you for also putting your comment, although we will be only addressing questions, so perhaps we can move to the next one. And the next one is, breeders will always evaluate variety before putting on the market. Marker-assisted breeders make the process faster but still safe, same for NGTs. Again, as with the previous one, I don't see it being a question, so I'm just gonna move to the next one, and hopefully we're gonna get more questions to panelists. So here a question to Fabian. European Commission consulted an option of pre-notification to provide evidence for absence of transgenic DNA and showing it is TMCM. I'm sorry, but I'm not familiar with this abbreviation. Perhaps Fabian, you are. Would this system be proportionate? If you want, I will allow you, of course, to take this question. However, I think it also very much relates to the European Commission and consultation of different options that are there. So if you prefer, we can also move to questions that are more science-based.
If we could specify what TMCM is, that would be great. I don't know this terminology, sorry. Oh, mutagenesis, cisgenesis, is that it?
Yes, targeted mutagenesis and cisgenesis.
Okay, so yeah, I think that this could be a good option. So if I understand well the question, it means that it says that there could be a pre-notification of what will be done in those plants, and ask whether this should be risk assessed or not. And I don't want to so I am not EFSA. I am just an expert in the GMO panel, but I think that this could be a proactive way for the risk assessment of those plants and of different traits that will arrive at EFSA. So yeah, I think it could be a good idea, even if we did not touch to that in the criteria that we propose, and that obviously it's more a question for the Commission than for EFSA.
Perfect. Thank you, Fabian, for clarification here. Yes, I see that there are two other hands up, so perhaps I'll let Jean-Christophe quickly comment, because I see you wanted to say something, please.
It's a little bit weird, because that was the understanding I had from the criterion 1, in a way, the absence of DNA. But perhaps I missed something.
Yes, Fabian, please.
I suppose that the question was asking whether once you have demonstrated that the plant is not transgenic, could you go faster in terms of risk assessment? And I think that this could be a proposition, but again, I think that criteria 5 and 6 should still be there. And I think that it should not be a problem for a breeder to demonstrate that a plant has an history of safe use, if it has one. Yeah, so be proactive and prepare the applicant to what they should show or what they should demonstrate. I think is a good idea, but I think that we still need this demonstration that the product is safe.
Thank you, Fabian. I see that there are other hands up. However, I would not like to open the discussion here, since we would like to take as many questions as possible. So if you agree, if it's okay for panelists, I would just move to the next question now, to be able to take as many as possible. We have very limited time, and the audience has been already very patient waiting for their answers. And I see that the next question that comes is a question for Ricarda about what type of evidence would you need to fully accept and support that the NGTs do not pose an environmental or human health risk, safety risk. Ricarda, would you like to take this question?
We just need to read it again. What type of evidence would I need to fully accept and support it? Basically, in that it would need to have the scientific data that that show that there is no risk. I mean, that they are working as perfect as intended, and that neither a side effect comes with the intended changes nor with the unintended changes that would be harmful to the environment or to their performance, and would therefore, for example, require more pesticides as support to them, or if they, for example, would not communicate well with pollinators, then all these things would come through in tests, right? So if there's nothing, then it's fine, but it has to be based on scientific data and not on assumptions. That is what is important to me here. I hope that clarifies. I mean, for me, for example, it does not mean if something is coming from an organism that is regarded as a foreign species to the receiving organism, that makes it automatically unsafe, or vice versa, if it's coming from a close relative, that it would make it safe. It is really about the placement and the context within the genetic setup, because it is about epigenetics, it's about gene regulation that actually the whole network works. So we cannot per se, by a certain mutation, say what the consequences are without testing.
Thank you, Ricarda. And I see that there are also quite a lot of reactions from the audience. So you're definitely captured something that is of interest and passion of many people who are following us here today. I will give the floor quickly to Helmut, and after that we'll take one more question before we close the Q&As to be able to wrap up. So Helmut, please go ahead.
Thank you very much, Magdalena. Briefly, also from my side, as Environment Agency Austria, we are assisting regulatory authorities in risk assessment, and I think it is a prerequisite to have a thorough and scientifically based risk assessment according to the criteria which are available for that purpose. To go through it, to use the available or the produced data, maybe if there is needed additional data. For good reasons, and understandable reasons, we have not addressed the data requirement issue today, but for a risk assessment, this is of course extremely important. And on the basis of that, and not prejudging any risk assessment on assumptions, but on real data on a scientific basis, we would be in a situation to answer this type of question. Thank you.
Perfect. Thank you, Helmut, for this additional information. I look at another question here, which asks about, do you believe that a strict risk assessment will increase the acceptance of NGTs by the public? It is indeed a very interesting question. However, I think it goes beyond the scope of this discussion, which is very much about science and scientific risk assessment and not so much about the public. So perhaps I'll just move to the next one, which is to Christoph. Or something has changed, sorry. Something has changed in the meantime. I'll just go for the top one. And Philippe Dumont says, as no biochemical differences exist between mutations, whatever method is used, why not apply exemption mechanism at the end of proportionate risk assessment? So I see here's a suggestion, and I wonder if any of you would like to comment on that to finish this part of Q&As. Okay, Petra, please, the floor is yours.
Yeah, I think this question also is related to a question that we had earlier to Nicoletta, I guess, regarding how other countries approach the NGTs. And actually, that could be something which is maybe in line with those approaches taken in other parts of the world. So taking a view at the product and assess if it has a conventional like risk profile, and then depending on the outcome, either include or exempt it from biotech regulation. So I think that's an important point, and that's also something I wanted to mention. So really also not only look at Europe, but also how other countries do, and many more countries do, and that could probably also help to have a system here which is practical and aligned with other approaches.
Thank you, Petra, for this. I will give the floor now to Christoph as the last one for today in this Q&A. And I also would like to remind the audience, if you would still like to get your questions answered, and if they're in the scope of this event and fall under the mandate of EFSA, you can always go to EFSA's website and ask a question to EFSA, and it will be answered. So Christoph, please, the floor is yours.
Yeah, the last question and now the actual question, which is up on the line. If you ask for biochemical differences in the mutations, this I think is a question which is not very relevant for risk assessment. The question for risk assessment which is relevant is what is the site, which is the site of the genetic change, and what is the genetic combination which is resulting from, and what biological effects, direct or indirect, you could expect. These are the questions you have to answer. And as far as we see from current publications, the intended and the unintended effects derived from NGT processes can be different from those which you could expect from conventional breeding. And this needs to be sorted out. Thank you very much.
Perfect. Thank you, Christoph, and thank you for allowing with your efficiency to take one more question. That will be the end of the Q&As for today. And thank you all for joining us today. As I said, you can go to the EFSA website if you would like to get answers to your questions, if they're in the scope of this event. And now I would like to give the floor back to Miro. Thank you all to all the panelists as well.
Thank you very much, Magdalena. Development, so to say. And I understood that Anna would also like to finalize this Q&A session by choosing a question that particularly appeals to her. So Anna, please, you have the last word in this Q&A session.
I hope I unmuted. I've pressed several buttons at the same time and something happened. No, we made a decision to try and be impartial and let the audience ask as many questions and vote for the questions. But then I kept on following the other questions and I was like, oh, I hope someone votes on this question and comes along and says. And I think they have quite a lot to do. So in the end, I ended up with 5 different questions, which in fact I will not be able. Some of them of these interesting questions have to do with how is EFSA going to assess the impact on environment. And I think this Helmut also talked about it during his statement. There was questions about stability and how is that going to be assessed, which is another area which we're very interested. And then there was one question which was very much more technical and that I would like to ask you. And it's about, the question read as, what about the circumstances that every NGT breeding process starts with the synthesis of a GMO with established genomic techniques to introduce CRISP information into the target plant? I don't know. Can anyone answer to me and to the person that... And the other questions, I will keep them on my notebook for later. Oh, I have lots of answers.
Yeah, so I thought we had Christoph first, and then Thomas, Petra, and Ricarda.
So yes, I think that's an important point also in regard to the unintended effects. And EFSA says we first have to check whether the plant is no longer transgenic. But this does not mean that the unintended effects, which were caused by the introduction by EGT technology in the first step to introduce the DNA of the genes into the plant, is really gone from is really vanished from the genome of the plants. So it's a highly complex issue to find out already on this first step what unintended effects are there derived from the first step for the introduction of the DNA for the gene sensor, and how can these be assessed, identified, and then qualified in risk assessment. And this is not answered by the current statement of EFSA. EFSA only asks whether the plant is inheriting a transgene, but this is something which is largely different from the question as raised now by this audience. Thank you very much.
Thank you very much, Petra. Oh, sorry, Thomas, Petra, and Ricarda.
Yeah, sure. So it's not necessary to integrate CRISPR DNA to get a mutation with NGTs. You can deliver RNA or protein. So these would not be classical GMOs. So there are other ways that we can deliver the reagents.
Thank you, Petra.
First of all, fully agree with Thomas' statement. So there are many different ways how to use the CRISPR-Cas tool or the gene editing tool. It must not be introduction of transgenic, but even if it is, and the transgenic DNA is no longer in the genome, it should be no longer regarded as any kind of GMO, and that would also be consistent with the approaches taken in other parts of the world. So no need to go into a risk assessment on no longer existing transgenic DNA.
Thank you. Ricardo, you will have the last word on this.
Thank you kindly. I find that in most cases, it still is being introduced as in the GM processes. There are new ways being experimented with, but they also can have, as one has to use protoplasts, they have their own risks with them. So one needs to check which process is being used, so it's process dependent. It is, for me, not, as Christoph mentioned, it's not only about whether some foreign DNA is still present, which often are not seen if you just use whole genome sequences. You need to have the long read whole genome sequencing in order to establish that anyway. And it is the background that gets created, the genome-wide mutations that get created by these processes. And in the past, I mean, it's the back-crossing exactly that helps to get rid of these unwanted mutations. But if the new techniques are intended to be used in a rapid way without efficient and sufficient back-crossing, then that safety net is actually not there. And as I mentioned before, for trees, for example, we have not mentioned that at all here as a problem. Whilst for risk assessment, it's a severe problem. That is also something I feel EFSA will need to investigate a bit more before progressing and just doing a general plant guidance here. Thank you.
Thank you very much. Thank you very much, all. Thank you for these last reactions within the Q&A session. It is not completely over yet, but the task is finished for our distinguished panelists. So I would like to invite you to now leave the stage, and thanking you once more for your contribution, for being with us. Thank you, Helmut. Thank you, Thomas. Thank you, Petra. Thank you, Jean-Christophe. Thank you, Ricarda. Thank you, Christophe and Fabien. Thank you very much. I would also like to thank the public for being with us, for talking to us, for discussion with the panelists, and finally to draw some conclusions from our event. So how was our event? I would like to invite Anna on the stage for the wrap-up and conclusions. Anna, are you with us?
I'm here, and my
Great.
microphone is working.
So how are you? It has been
I'm fine. It was quite a lot of preparation. I'm very happy that we had so many attendants. I think I really would like to thank the panelists. They were excellent. And you, Miro, I think you did a fantastic job in keeping time and giving the same opportunity to all our panelists. So
it has
very
been a long
happy.
day. Yeah, thank you very much. I would still like you to make one last effort and answer some questions, if you don't mind.
Please.
So, for you, what are the two most important takeaways from today's session?
I think it confirmed some of our questions that we have posed, and the statement comes as well with a series of recommendations or additional considerations, points that are needed to be further explored. And to that list, I've added a few points, which of course I will discuss with my colleagues and the GMO panel in due time. So that was definitely very interesting. Also a confirmation, but also that there are in fact very strong views about this matter, which is no surprise. But in the middle of these strong views, very interesting arguments that are needing to be explored. We always have a feeling as EFSA in this job that you can never please everybody, but that's not the point. We're not here to please anyone. No, we are here to do our job, and we do that as serious as we can. And these kind of events serve to also bring new inputs. So for all of that, I think this will be my main takeaways.
Thank you very much. And what would then be your next steps?
Well, the next steps, we have more work. As EFSA, mandated by the Commission, we have received a new mandate regarding risks and suitability of risk assessment guidelines for the assessment of the genetically modified microorganisms by new genomic techniques. And we believe we may have to also work on animals. This is another area. So that will keep us busy. And the rest we leave to our colleagues in the European Commission to mandate us, or our colleagues in the member states, which can also mandate EFSA to continue work in this area. At the moment, these are the next activities. Of course, we have a bit of activities to reflect in everything we've learned today, and also make available all the material from presentations and recording into our website. So stay with us. This will be there. And please don't hesitate in sending any additional questions you may have through Ask EFSA.